Very good morning to all of you. I cordially welcome you all for this Engineering Thermodynamics course U18 ME 305. In the today's class, we have to discuss about the units and dimensions. So that is already the units and dimensions of various thermodynamic parameters are known to you. So that's why this topic is treated as self-learning topic. So under this self-learning topic, we have to discuss units and dimensions of the various thermodynamic parameters. And what is the motivation? That is why we have to study these units and dimensions. Because these are very important one, the units as well as the dimensions as well as their conversion factors to solve the various numerical problems in the engineering thermodynamics course. That is, without having a prerequisite knowledge about the units, dimensions, and their conversion factors, so we are not in a position to solve any numerical problem in engineering thermodynamics course. So that's why these are very essential. And every course or every lecture is having some objectives as well as the outcomes. And what is the outcome of this lecture is, so after completion of this lecture, you should be able to explain units, dimensions, and their conversion factors of the various thermodynamic parameters. So now let us see, so what are the important thermodynamic parameters normally we are going to come across whenever we are studying this course. The first foremost important parameter is the force. So we know that the force SI unit is Newton, and whenever we are talking about the various conversion factors, so 1 Newton is equivalent to 1 kg meter per second square, and 1 kg force is equivalent to 9.81 newtons. And the second important thermodynamic parameter is pressure. And we know that pressure can be defined as it is a force per unit area. So force units are nothing but newtons and area units are meter square. So that's why the SI unit of the pressure is normally Newton per meter square. And among the existing available thermodynamic parameters, especially the pressure parameter and its the conversion factors are very important while solving the problems. Because normally in the data, he will be given the pressure is equivalent to some 1 bar. So how can you convert 1 bar into 1 Newton per meter square? That is SI unit. So that is you should have some thorough idea about the conversion factors. So that is the what are the various units of the pressure first of all. So bar is 1 unit, atmosphere, mm of Hg, centimeter of Hg, Pascal, and atmosphere, kg force per centimeter square, kg per meter second square. So like this we can have the various units for the pressure. And we know that 1 atmosphere is equivalent to 760 mm of Hg or 776 centimeters of Hg. So 76 centimeters of Hg or 760 mm of Hg. So 1 atmosphere can be written in terms of the bar as 1.01325 bar. So 1 bar is equivalent to 10 to the power of 5 pascals. 1 pascal is equivalent to 1 Newton per meter square. Hence, 1 atmosphere can be written as 1.01325 into 10 to the power of 5 Newton per meter square. So 1 bar equivalent to 10 to the power of 5 pascals and 1 pascal is equivalent to 1 Newton per meter square. And here another unit is also there for the pressure, that is the torr, TORR, torr. So it is also used to measure the vacuum pressure. Vacuum pressure. So 1 torr is equivalent to 1 mm of Hg. Like that we can have the conversion factor. So next, the third important thermodynamic parameter is work or energy or heat. All are having the similar units. So here 1 joule, that is normally what is the SI unit for the work is 1 joule. So 1 joule, because the work is nothing but force into displacement. So force is Newton, displacement is meter. So 1 Newton meter, it is equivalent to 1 joule or it is 1 watt second. And another important units are calories. Calories and joules is very important one. So the conversion factor between the calories and the joules should be known to everyone. 1 calorie is equivalent to 4.184 joules, or normally in our calculation purpose we are taking it as 4.2 joules. So like that we can have the conversion between the calorie as well as joule. So the next one is the power. So power SI unit is watt, that is the joule per second. So joule per second is nothing but it is the work per the displacement, that is the work per the unit time. So that is the joule per second. So that is equivalent to 1 watt. And normally whenever we are purchasing any electrical motors, so they can be in the form of the HPs, is the 0.5 HP motor, 1 HP motor, 2 HP motor, like that. So what is the conversion factor between the HP and the watt? So 1 HP normally it can be equivalent to 736 or 735.3 watts, and 1 kilowatt. So kilowatt is nothing but kilo means 10 to the power of 3, that is 1000. So 1 kilowatt is equivalent to 1000 watts. So like that we can have the units for the power. So similarly the specific heat. So specific heat that is nothing but Q is equivalent to MC into delta T. So C is equivalent to Q by M into delta T. So Q units are normally joules per kg Kelvin. So joules per kg Kelvin are normally calories per kg Kelvin. So like that we can have the specific heat units. Next one is the thermal conductivity. So thermal conductivity is nothing but the ability of a material to conduct the heat. That is the meaning of the thermal conductivity, which is normally denoted by capital K. So K is the symbol for the thermal conductivity. And all of you, most of you aware that what do you mean by the Fourier's law of heat conduction? That is the three primary modes of heat transfer are there. One is the conduction, second one is the convection, and the third one is the radiation. So in the conduction, we are having the Fourier's law of heat conduction, that is Q is equivalent to minus K into A into dt by dx. So where K is a constant, that is known as the thermal conductivity. So thermal, according to Q equivalent to minus K into A into dt by dx. So we are able to have the thermal conductivity units are equivalent to watt per meter Kelvin. And similarly here we are having the heat transfer coefficient also is there. So once again it is from the Newton's law of cooling, another mode of heat transfer. So like that we are having the important thermodynamic parameters are there, and every student should be in a position to know what are the units, dimensions, and similarly the thermodynamic parameters, which are very important while we are solving the numerical problems. So I wish you all the best. We will meet you in the next lecture. Thank you.